In Atwood's machine consists of two masses, mass 1 equals 8 kilograms and mass 2 equals 10 kilograms. Both are suspended from a pulley that is massless and frictionless. What amount of time, t, does it take for the larger mass, m2, to descend from 5 meters when the system is released from rest? Find the tension of the cord connecting m1 and m2 as they descend. What is the acceleration of both masses? Use gravity, g, equals 10 meters per second squared. So the first thing we're going to do is draw a free body diagram in order to label all the forces acting on the masses. So we have the circle here, which is just the pulley, and then there's these two cables on both sides, and this one's going to be m2 and this one's going to be m1. And since m2 is heavier than m1, this is going to be pulling down as m1 goes up, which means, just so you know, the acceleration here is up and the acceleration here is downward. Now both of these are going to have force of gravity acting upon them downward. We're going to label this one as a force of gravity, or F1g, and we'll label this one F2g since their masses are different. But both of them are going to have force of tension acting up, and they're going to have the same force of tension. So this is going to be F sub t, and this is going to be F sub t as well. So here's the pulley. Here is force of tension acting up on both of them, and they have their two separate force of gravities acting down. And this is going to be accelerating downward since the weight is heavier as this one accelerates up. So now that we have our free body diagram, we can begin to solve the problem. So first of all, I'm just going to write down the two givens that we know. We know m1 equals 8 kilograms and m2 equals 10 kilograms. Next we can use Newton's second law, which is F net equals ma, and that basically means the net sum of all the forces acting on the mass are equal to the weight times the acceleration, or the mass times the acceleration. So here we can see on mass 1, the net force is going to be the difference between the tension going up and the force of gravity going down. And then we have the mass here. And this is going to be for the first mass. So we can write F net is equal to m1a, since this is for mass 1. And as I mentioned earlier, the difference between the force of tension going up and the force of gravity going down are going to be equal to m1a, or the mass times the acceleration. So we can rewrite F net as f of t minus f of g, and that equals m1a. Now we can rewrite this one more time because we know the force of gravity is equal to mass times gravity, which is which, as the problem mentions, is 10 meters per second squared. So we can write this as ft minus m1g equals m1a, since force of gravity is mass times gravity. Now next, we're going to move the m1g to this side so we can just isolate what ft is equal to. So ft equals m1a plus m1g. Now we're going to focus on the second mass, which essentially has the same difference in the net forces, which is going to be the difference between force of tension and the force of gravity. Alright, so now that we have the equation for the first mass, we can begin to focus on the second mass. So, just like the first mass, we know here that the net difference between the forces is just going to be the difference between F of tension and force of gravity. But this time, the acceleration is going downwards, and this is going to mean that the acceleration is going to be negative. So, when we write out our equation here, F net is going to be equal to negative m2a, since the acceleration is going downwards, and that means it's going to be a negative. So, now we can rewrite F net, just like the first problem, as f of t minus f of g equals negative m2a. And once again, just like the first part of the problem, we can rewrite f of g as m2g, since this is the second mass, not the first mass. So f of t minus m2g equals negative m2a. Now, if we look to the first equation we had here, we solved for f of t as being m1a plus m1g. And now we can take this equation for f of t and plug it here for f of t. So if we plug this in here, we get m1a plus m1g then minus m2g is equal to negative m2a. So now with this, we can just move things to different sides in order to isolate the acceleration, since that's what we want to solve. So I'm going to move this m1g to this side and this m2g to this side, and we're going to move the negative m2a to that side. So now we're going to get m1a plus m2a equals m2g minus m1g. So now what we can do is factor out this value of a, which is the acceleration. So we get a times m1 plus m2 is equal to m2g minus m1g. Now we can just divide both sides by m1 plus m2 in order to solve for a. So that's going to get a is equal to m2g minus m1g all over m1 plus m2. Now one last thing we can do to make this even more simpler is factor out this g here. So our equation for a is going to be a equals g m2 minus m1 all over m1 plus m2. Now that we have the equation, we can just plug in the values that we already know in order to solve for the acceleration of the masses. So we know the g, according to the problem, we should use 10 meters per second squared. And then we know m2 equals 10 kilograms and m1 is 8 kilograms all over m1 plus m2, which is going to be 8 plus 10. Now if we simplify this, we get a is equal to 20 over 18, and we can just divide this here. 20 divided by 18 is equal to 1.1. So we know a is equal to 1.11 meters per second squared. So that's the first part of the problem. Now, the second part of the problem here is find the tension of the cord connecting m1 and m2 as they descend. So we can actually go back to the first equation we had, which was that f of t is m1a plus m1g, which we got earlier as we began to solve the problem. So you can rewrite this by factoring out this m1 and just get f of t equals m1a plus g. Now, we just solved for a as being 1.11 meters per second squared, and we know m1 and g. So we know that f of t equals, and m1 is 8 kilograms times acceleration, which is 1.11, plus g, which the problem says is 10 meters per second squared. So this is just equal to 11.11. So we know f of t equals 8 times 11.11. Now we can do that with our calculator right here. So 8 times 11.11 is equal to 88.88, and that's going to be the tension on the cable. So f of t equals 88.88 newtons. Okay, so now that we know the tension and the acceleration, we can do the last part of the problem. Now we could have solved for time earlier, but I just found the tension first because we already had the equation for it. But the last part of the problem is, what amount of time t does it take for the larger mass m2 to descend from 5 meters when the system is released from rest? So what we're going to have to do is use one of our UAM equations, and that's going to be delta y is equal to v0t plus 1/2 at squared. Now, I'm going to write down the givens that we already know. We know the initial velocity is equal to 0 meters per second because it says that it's released from rest. Now we know delta y, which is the distance traveled, is equal to 5 meters, since that's just what it says in the problem. And lastly, since we solve for the acceleration, we know it's equal to 1.11 meters per second squared. Now we can just begin to plug in the givens we already know. So we know 5 is equal to And since the initial velocity is equal to 0, you're just going to get 0 multiplied by time, and that's just going to equal 0. So 0 plus 1/2, and the acceleration is equal to 1.11, and then there's t squared, which is what we want to solve. So let me get our calculator here, and we can multiply 1/2, which is just 0.5, times 1.11, which is the acceleration, and then we get 0.555. So now you have 5, which is the delta y, is equal to 0.555 t squared. Now you can divide both sides by 0.555, and I'm going to do that here. I'm going to divide 5 by 0.555, and the number you get, we'll just leave it approximately equal to 9. So then you get 9 is equal to t squared. Now you just find the square root of both sides, and square root of 9 is equal to 3, so you know t is equal to 3 seconds. So now we've solved all 3 parts of the problem. We know the time is equal to 3 seconds. We know the acceleration is equal to 1.11 meters per second squared. And lastly, we know the force of tension is equal to 88.88 newtons. We hope you enjoyed our tutorial.
Bye.
Bye.